Today, I'll be talking about training language models to follow instruction with human feedback. This paper is from OpenAI. And this is the technology behind the chatGPT. Large language models can be fine-tuned to perform various natural language processing tasks, such as questions answering and chat. However, making language models bigger doesn't make them better at following users' intent. The outputs can be untruthful, toxic, or simply not helpful. In other words, models are not aligned with their users. One approach of language model alignment is to fine-tune language models using reinforcement learning from human feedback. Reinforcement learning has been applied to fine-tuning language models to summarize text. Human feedback is used as reward in domains such as dialogue, translation, semantic parsing, story generation, review generation, and evidence extraction. There has been non-direct application of reinforcement learning with human feedback to aligning language models on multiple language tasks. And also the question of what it means for language model to be aligned has also received attention. In this work, the goal is to align language model with user intention on the wide range of tasks by fine-tuning with human feedback. In this section, we present high-level methodology for language model alignment. This method starts with a pre-trained large language model, then a variety of requests of different tasks waiting for this language model to solve, and a team of trained human labelers who prepare training data for this language model by sampling random requests and answer them. These methods generally include 3 steps. In step 1, we prepare supervised data, then fine-tune pre-trained language model to specific natural language processing tasks using these supervised data. In step 2, we also prepare supervised training data, but this supervised training data is used to train a reward model to rank the language model's outputs. In step 3, given the reward model and the fine-tune language model, we optimize the fine-tune language model against the reward model using the reinforcement learning. And the step 2 and step 3 can be iterated continuously. In step 1, we fine-tune a pre-trained GPT-3 models using supervised data for set of tasks such as brainstorming, generation, rewrite to obtain the instruct GPT. The supervised data was built by sampling random prompt. For example, explain the moon landing to a 6-year-old. Then we ask the labeler to answer it. A gross entropy loss function is generally used in the supervised fine-tuning. The However, the total level loss functions is not sufficient to ensure the output being truthful, not toxic, and helpful to user. Moreover, the loss function can ensure generating coherent conversation for applications such as a chat, like the ChatGPT. Uh, As a result, the reward models uh, is trained to evaluate the output of the instruct GPT. The reward model is trained on supervised data, and the evaluation from the reward model on the output of instruct GPT can be used in additional loss function to improve the quality of the outputs in terms of uh, its alignment to user intent. The supervised data was built by asking the labeler to rank several model outputs for a given input. In the last step, we optimize the instruct GPT or our large language model against the reward model using reinforcement learning loss. Specifically, the re the reward model is fixed during the process. Instruct GPT is updated to generate output that maximize the reward from reward model. Note that uh, because we don't have target output for instruct GPT, this is an unsupervised training. In this section, we uh, we present the evaluation of the instruct GPT on user submitted prompt and on the public datasets. The experiments compare the proposed methods denoted as PPO, PTX, and PPO, or the reinforcement learning system to supervise fine-tune GPT-3, which is obtained in step 1, and also the pre-trained GPT-3, which is given from very beginning. The metric for evaluation is human preference, which means we will ask the labeler to rank the output of proposed method and the other methods. Among all systems, for example, among all systems, which outputs it prefers most or less. And we also want to learn, does system follow instruction? And or it can correct the wrong instruction. And moreover, there is less likely make up information or hallucinate. The figure shows that the proposed methods or, reinforcement learning methods are best system in terms of human preference. The reinforcement learning method, which is the orange line and the red line, improve the performance of the supervised fine-tuned, which is the green line. So the takeaway here is that The best performance of the instruct GPTs comes from combining supervised fine-tuning with reinforcement learning using human feedback. Moreover, a different aspect of the proposed methods also been evaluated, such as the attempts to correct uh, wrong instruction, or that is follow the um, specified constraint, or that is hallucinate. And the figures show that the proposed methods perform the best for majority of the design characteristic. However, the proposed methods still hallucinate and or make up the information. On for evaluation on public datasets, the truthful question answering dataset is used to evaluate the truthfulness. Also, the toxicity is evaluated on the real toxicity prompts datasets. On the two figures, the gray bars show the human preference for truthfulness. And as we can see, the instruct GPT outperforms the pre-trained GPT-3. And from the figures, we can also see that the instruct GPT is less toxic than GPT-3 in respectful prompt. For qualitative results, instruct GPT show promising generalization to minority tasks in fine-tuning data, such as tasks in non-English language. However, the instruct GPT still makes simple mistakes. When given instruction with false premise, the model sometimes assume the instruction is true, and it overly hedge, which is if we give the multiple possible answer or very long answer to a very simple question. And also, its performance degrades when instructions contain multiple constraints. For example, listing 10 movies made in 1930s set in France. Discussion. When we're talking about user alignments, so the first question is, who are the model aligned to? So the instruct GPTs is aligned to preferences of human labeler and researchers who designed this study. This paper's goal is to demonstrate a technique that can align the model to specific human preference group for specific application. And this study doesn't claim that researchers and labelers are right source of preferences. And what is the limitation of this kind of system? The behavior of instruct GPT is determined by human feedback from labelers. Therefore, their judgment may be impacted by identity, beliefs, cultural backgrounds, and personal history. And clearly, This group is not representative of full spectrum of people who will use and be affected by deployed models. And the InstructGPT is neither fully alive nor fully safe. Conclusion. This paper presents methods that can align GPT-3, a large language model, to specific human preference group in specific tasks. The proposed system consistently outperform the pre-trained large language model in terms of human preference, which indicates the efficacy of reinforcement learning with human feedback. However, this model is neither fully aligned nor fully safe. Thanks for your attention.